Hey guys, today we're going to talk about the square root property. Now this is another method that we can use to solve an equation, and it's really useful obviously if we have something squared to get the square to cancel out by using the inverse operation of a square root. So what this property says is if you have x squared is equal to n, and n has to be greater than or equal to 0, we need a positive number here. Then what it's saying is you can take the square root of both sides, and the square root of x squared is x. So x would equal plus or minus the square root of n. Make sure we have the plus or minus there. That's the really important thing here. You don't want to just have the principal square root. You want to have both the positive and the negative. So an example of this would be like x squared equals 25. You can take the square root of both sides, and you'll end up with x equals plus or minus square root of 25, which we know is plus or minus 5. So your solution set would be -5 and +5. And if you were to go back to your original equation, if you square -5, you end up with +25. If you square +5, you end up with +25 as well. So this is another method we can use to solve equations. And we'll go through some examples of this. This will be really useful as we go on further. So our first example we have is 4x squared equals 36. Now we could solve this using the zero product property. We could subtract the 36 and factor out and see what we have, but we're going to do this with the square root property. So both sides you can take the square root. So square root of 4x squared equals, plus or minus again is really important, plus or minus the square root of 36. Well, the square root of 4x squared, that's 2x. If you square 2x, you get 4x squared. Square root of 36 is plus or minus 6. So now we kind of have two cases here. You have the case that 2x equals +6, in which case x equals 3. Or you have the case that 2x equals -6, in which case x would be -3. So our solution set would be -3 and 3. Those are our possible solutions here. You could always check by substituting back into your original equation, but here's how you can use the square root property. Take the square root of both sides. Now where this comes up, when we'll see it in the future especially being really important, is if we have like a binomial squared. So again, if we really wanted to, we could expand this out, do y minus 6 times y minus 6, bring the 81 over and try to use the zero product property, but we have two perfect squares, so why not take the square root of both sides? So plus or minus square root of 81, we have the square root of y minus 6 squared, and this might look a little confusing, but really when you take anything squared and take the square root, you're just left with the base, like this is equal to x here. So your base here is the binomial y minus 6. So it's y minus 6 squared, you're taking the square root, you're left with y minus 6. That's your base there. Then over here you're going to have plus or minus, well, square root of 81 is 9. So let's think of our two cases. We have the case where y minus 6 equals the +9, in which case y is 15. And you also have the case where y minus 6 equals the -9. In which case you add your 6 and y is going to be -3. So these would be your two solutions, -3 and 15. You could always substitute back in here and see that they'll both give you 81 when you substitute your y in here. So here's another way you can use the square root property. On to our next. So we have x squared minus 16x plus 64 equals 25. And again, it looks like we have perfect squares. You could subtract the 25 and use the zero product property, but I want to show us how we can use the square root property. There will be times in the future where factoring isn't a possibility to solve an equation, and we need to kind of make perfect squares. It's a method called completing the square, and then we're going to rely on this property. But right now, we have perfect squares, so don't have to worry yet. So we're going to take plus or minus the square root of 25 over here. On this side, Actually, before we even do this, we'll just leave it as 25 for now. On this side, let's write this as a binomial squared. This is a perfect square, so we're going to have x, and then we're going to end up with, we have that minus in the middle, minus 8. You can check and find out this is a perfect square. If this side wasn't a perfect square, we'd have to subtract the 25 and try to factor out. But it is, so we can now take the square root of both sides. Take the square root, plus or minus our square root over here. So again, your binomial is the base, you're squaring the binomial, and then taking the square root of it, and then we're going to have plus or minus 5 over here. So let's account for a couple of cases. One case is x minus 8 equals your positive 5, in which case x is 13. And you also have the case where x minus 8 equals the negative 5, in which case your x would equal, where you add your 8, you're going to end up with x is equal to 3. So your solution set is going to be the set containing just 3 and 13. You could always substitute back into your original to check and see if these work. Alright, so we're going to try, if you want to go try some of these on your own, you can. There's a slide with 4 more practice problems. I'll go through those 4 problems now if you want to try them and then check the work with what I do. So the first one, we have 9x squared equals 49, and we're going to use the square root property here. So I'm going to take the square root of both sides, plus or minus square root of 49. Well, over here, the square root of 9x squared is 3x, square root of 49, plus or minus 7. So we have 2 cases, either 3x equals 7, in which case x is 7/3, or 3x equals the negative 7, in which case x is negative 7/3. So your solution set is the set containing negative 7/3 and 7/3. That was our first. Next one, we'll do the red one to the top right in the slides. We have a minus 10 squared equals 121. Notice both sides are a perfect square, which should be like an indicator that the square root property is a good way to go. So we have a minus 10 squared is equal to square root of 121. Don't forget the plus or minus. And now we're just going to take the square roots of both sides. So you're squaring the binomial, then taking the square root. You're left with just the binomial, and that equals plus or minus 11. All right, our 2 cases. A minus 10 could equal the positive 11, in which case a is 21. Or we could have a minus 10 equals the negative 11, and then a would be negative 1. So our solution set is the set containing negative 1 and 21. These are our possible solutions for this equation. We have 2 more to try, then you can go try some of these on your own. So we have 4x squared plus 12x plus 9 is equal to 16. And let's see if this right side is a perfect square. If it is, then we can use the square root property. If it's not, we'd have to subtract the 16 and fall back on that zero product property. So to check to see if this is a perfect square, well, you take the square root of this term, that would be 2x. Square root of this term would be 3. So these are both perfect squares, and if you do 2 times those 2 square roots, you get the middle term. So this is a perfect square, and it would be 2x, that's your a, plus your 3, and that equals 16. And now we can take the square root of both sides. So when you take the square root of the left, you have 2x plus 3. When you take the square root of the right, you have plus or minus 4. So let's make our 2 cases. 2x minus 3, or 2x plus 3, equals positive 4. So 2x equals 1. X could equal 1/2. That's one case. And we have the case where 2x plus 3 equals the negative 4, in which case 2x equals negative 7. So x equals negative 7/2. So our solution set is the set containing negative 7/2 and positive 1/2, and we're all done. All right, on to our last problem of the day. This one we have 81x squared minus 90x plus 17 equals -8. Now for this one, we can check to see if this is a perfect square, but even right off the bat, you might notice the right side isn't a perfect square, and it's going to be kind of a mess to do things. And also, this trinomial isn't a perfect square either. So our method here would be, well, now we can try to fall back on the zero product property. And we have 81 minus 90x. Let's add that 8 to both sides. And we're going to see that we get 25 here. And I'll talk about another method, another type of thinking that we should start to kind of use for this one, because it'll come up in the future and it's a really useful method. Can we factor this? Well, no GCF, not a difference of squares. Notice the first term is a perfect square. First term, the square root of 81x squared would be 9x. Square root of 25 would be 5. Multiply those together, you get 45. Of course, you would take 2 times that, so you get the -90. And that means we have a perfect square. 9x, square root of this, minus square root of 25 is -5, and we're squaring it. This factored is right down here. We could take the square root of both sides here, or you could even think of it like the zero product property. 9x minus 5, in order for this to be 0, this binomial here has to be 0. So we really only have one case here. It's going to be if 9x minus 5 equals 0. And when you solve, go right over here, you add 5 to both sides, divide by 9, your solution set is 5/9. And just like that, we're done. So I do want to talk about one other thing with this, because we will do this in the future, and it's just a type of thinking of using the square root property how you can. If you were to look to the left here, if you were to ignore the right side and just look to the left, you might notice that this term is a perfect square, and this one is not, but it's close to being a perfect square. And there's going to be different methods that we talk about how to recognize this. But one method to using this property is figuring out how to make this a perfect square. And the method you can use to make this a perfect square, and again, we'll talk about this in the future, is to make this a 25 though, for this particular trinomial. If this was a 25, then it would be a perfect square, and you have to add 8. It just so happens that you had -8 over here, so it worked out really nice. It won't always do that, but that thinking of what should your C term be to make it a perfect square, that's a really useful method. It's called completing the square, and we'll talk about that in the future. So for now, just practice the other ones that we have. Have a nice day.